Hey, in this video, we're going to talk about how to find in 3 dimensions the distance between two lines that don't intersect, two skew lines. Okay, let's discuss this with an example. Here it is. Okay, so first of all, conceptually, we basically have two lines. Let's say one like this, right? Maybe one like this. And this is, let's say, going in and out of the page. This is more going towards side to side. Okay. Actually, maybe I should make it like that. This is side to side, and this is going in and out of the page. Okay. And they don't hit each other. So at some point, there's going to be a shortest distance between the two, right? The two lines, like this. Okay, but how do we find that distance? That's the question. Okay, here's the concept, okay? See this direction here? What we're gonna do is, we're gonna add that direction, that parallel direction, to this line, okay? If you have two directions and a point, okay, we can form a plane, like this. We're gonna get this direction, okay? And then add it to this direction at the bottom as well. Like so, and that would also form a plane, okay? And because the top plane, this top plane here, okay, and I'm just gonna circle it just so you can see the texture is different. These two planes must be parallel because they have the exact same two direction vectors. So now it makes sense, okay. That means the shortest distance between the two lines must be the perpendicular distance between the two planes. So this is the approach, okay? All right, so one thing for this question, once we have a plane, we can easily find, okay, once we have, let's say, ax plus by plus cz plus d, the scalar equation of a plane, okay? We can find the distance to a point that's not on the plane with the following formula, okay? And this is through scalar projection, which I'm not going to prove in this, okay? It is proved in a separate video, but it's the following. Absolute value of ax0, by0, cz0 plus d is equal to the square root of a squared b squared plus c squared. So this formula here, if you have a plane, you have a point floating somewhere outside of the plane, you want to find the shortest distance, okay, from that point to this plane, this is the formula that would do it, okay? So what do we have to do here? We need to find an equation of a plane that contains this line entirely, but also contains this direction. Okay, so we have two directions, so we can find a normal, which contains this line and this direction. Okay, so the normal we can get by, okay, let me write it up here, 5, 1, 3, 5, 1, negative 2, 4, 1, negative 2, 4. So you get 1 minus 12, minus 6 minus 5, 20 plus 2. Okay, we get this, okay? But you can divide this by negative 11 to get 1, 1, negative 2. Okay, so which means our plane will look like this. A is 1, so 1x plus 1y minus 2z plus d is equal to 0. How do we find d? Well, we have a point that's on the plane, so just plug that in, right? 2, 6, 1, right? The only unknown now is d. So d is equal to, you can see, negative 6. So this top plane, okay, we can think of this top plane as, right, x plus y minus 2z minus 6 equals 0. Okay, so the shortest distance now between these two lines, skew line is same thing as the shortest distance between this plane and any point in this bottom plane. So we know that point right there is in the bottom plane. Okay, so all we have to do is now find the distance from this point, which is we can treat it as our P0 in this plane. So therefore the shortest distance, D, right? D is going to equal to, okay, 1 plus 5 minus 2 times by negative 3. And then minus 6, absolute value of that, and you square root and sum of those squares. So 1 squared, 5 squared, minus 3 squared, okay? Okay, so that's 6 minus 6 gone, and we have still another positive 6. 1 plus 25 plus 9, so 6 over, what is that, root 35. That's the shortest distance. Okay. All right. So this particular concept, it did confuse me a lot when I first did vectors. Okay. So it's multiple ideas. We're just combining them all into one. So you might have to watch a few times. But once you get it, it's pretty straightforward. That's it for this one. I'll see you in the next.